Okay, here we go. We're still looking at experimental probability here. And this example here talks about we have 6 marbles in a bag. Some are red and some are blue. Marbles are chosen at random and put back 100 times. The fact that they are put back, replacement, is important. And once that's done, the results are recorded. And so after 10 picks, we had 4 reds and 6 blues. After 50 picks, we had 10 and 40. And after 100 picks, we had 30 reds and 70 blues. So use the experimental data to calculate the probability of choosing a red ball. So the probability of choosing red, and make sure you use good probability notation. Probability of choosing red, well, this is our best estimate. It's going to be 30 out of 100 trials, which is 0.3. Is there the same number of red balls and blue balls? Well, the honest answer is we don't know, but based upon this outcome, I would say no. How many of each balls would I estimate? Well, my estimate is there would be 30 red and 70 blue. Now, if I wanted to get this estimate better, I would do more of these. I would do maybe 1,000 or 10,000, and that would get me more and more accurate using the experimental probability of the long run relative frequency of successful reds. So what's the percentage after doing lots and lots of trials is how we can find the probability. Let's look at another example here. Bob goes to the theater at 2 on a Saturday afternoon. He surveys the ages of people in the theater, and he determines there's 15 children, 3 teenagers, 7 adults, so in total of 25 people. He returns later that day at around 10 p.m. Oh, so this is 2, and this is 10 later on at night, with the thought of giving kitty treats to young children because Bob is so kind. Kind Bob. He knows the theater has sold out the entire 250 seats. Based upon his survey, how many should Bob expect? Well, I know the probability of children is 15 out of 25, which if I do the calculation, I know is which is equal to 0.6. And if I have 250 seats, I multiply that by the proportion 0.26, and I should estimate 150 children. This is equal to 150 children. Based upon this survey, that's how many children Bob should expect. Now, B part, the more important question, is this a reasonable estimate for Bob to make? Explain your thinking. Well, I would say the answer is no. And the reason being, as at 2 o'clock on a Saturday afternoon, I would expect there to be children at the theater. At 10 p.m., I do not expect the same amount of children proportionally to be in the theater. And so I would think the adults and teenagers would be higher, and this would be significantly less. And so it is not reasonable to estimate for Bob to use this survey because the conditions have changed. If we're going to use this survey, we need to keep the same conditions in order to do it. If not, you introduce a form of bias.